All right, today we begin section P3, and there's really not a lot to this section. We're going to start with the distance formula. Now, you guys probably have the distance formula memorized, which is good, but let's just briefly go over where the distance formula comes from. So suppose in a XY plane, and it doesn't necessarily have to be in the quadrant 1, but suppose you got 2 points. So the first point we can call P1 has coordinates x1, y1, and the second point has coordinates x2, y2. So where our goal is to find the distance between them. Now, the way you could do it is you could break it down into vertical and horizontal components, which of course are perpendicular to one another. So according to the way we labeled our points then, this distance horizontally from the first point to the second point is x2 minus x1. And this distance between these 2 points is y2 minus y1. Okay, so therefore, using the Pythagorean theorem, we could say that d squared is equal to x2 minus x1 squared plus y2 minus y1 squared, right? A squared equals b squared plus c squared. And then, therefore, d is simply the positive square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's where the distance formula comes from. You can go ahead and read examples if you want to, just see how the formula is executed. But we're going to go ahead and move on from there. And we're going to go ahead and go to the midpoint formula now. Now, the midpoint formula is ridiculously easy. Okay, so again, supposing you have 2 points, x1, x2, or sorry, x2, y1, x1, y1, and x2, y2. Sorry about that. So the midpoint is simply the average of the x coordinates and the average of the y coordinates. So an average, the way you find an average is you add them and you divide by 2, right? So therefore, this is your midpoint formula. Okay, very easy. Again, I'm not going to go over an example because you can look over it very easily. No problem. Okay, finally, the third part of our lesson has to do with translating points in a plane. So to do this, I will just use, well, that's kind of cool. Okay, let's look at example 8. So supposing you have a triangle with vertices at -1, 2, 1, -4, and 2, 3. So they want us to shift the triangle 3 units to the right and 2 units up. Okay, so shift it 3 to the right and 2 up. Okay, well, this is not difficult. So whenever you want to shift something to the right, you are adding to the x coordinate. So if you want to shift all 3 points to the right, you just have to add 3 to all of the x coordinates. Similarly, if you want to move everything 2 units up, that's the vertical component, then you would just add 2 to all of the y coordinates. So the result, therefore, would be, after the shift, -1 plus 3 is 2, 2 plus 2 is 4, so there's 1 point. 1 plus 3 is 4, -4 plus 2 is -2, and then 2 plus 3 is 5, 5 plus 3 is also 5. So these would be the resulting vertices if you were to apply those translations. Okay, and then continuing to our last example, if you look at example 9, this time they give you the vertices of a triangle at 1, 1, 4, 2, and 2, 4. And they want you to reflect the triangle in the y-axis. Okay, so let's think about this for a moment. If you have an object, and in this case, whatever, a triangle, I'm not drawing, obviously, the exact points, but if you want to take that and then rotate it around the y-axis, I don't know if that's the best drawing, but anyways, you have to think about what exactly is going to change. So when you rotate along the y-axis, will the height of each point change? Well, no, right? Like this point, if you go to the other side around the y-axis, will result in this point. And so you could see that the y-coordinate is the same. But what is different is that the x-coordinate is exactly the opposite. Similarly, if you start with this point and you rotate over the y-axis, maybe it'll end up here. And then similarly, if you take this point and you rotate it around the y-axis, maybe it'll end up here, right? So that gives you the reflected on the y-axis. Anyways, the result is an opposite x-coordinate, but the same y-coordinate. So therefore, the new points, if we were to actually do it with the actual values, would be the opposite x-coordinate, but the same y-coordinate. The opposite x-coordinate, the same y-coordinate. The opposite x-coordinate, the same y-coordinate. So those would be the new vertices after the reflection. And that concludes this brief video.